In exercise 85, use a graphing utility to graph the intersecting graphs of the equations and then algebraically show that they are orthogonal. So there are two parts in this exercise. The first is on the TI-Nspire, and the second one is really more on paper. But when we have two graphs like this, x plus y equals 0 and x equals sine y, we can't put any of them in the TI-Nspire as such. So of course we need to rearrange this. X plus y equals 0 is y equals negative x. As for this one, x equals sine y, it's y equals arcsine of x. On your calculator, we'll see how it works, but this is actually written inverse sine of x. So that's a bit of a problem in math because this -1 means two different things. It may mean inverse function. Here it means the arcsine, but it may sometimes also be 1 over sine x. So we need to be very aware because obviously 1 over sine x is not arcsine. 1 over sine x is cosecant x. So that is not correct, and the only way around that is to just be very aware what are we doing. In math, we try to avoid as much as possible these little problems. We try to make math as clean and unambiguous as possible, but sometimes there are little places where we still have ambiguities. So I'm going to plug these graphs in. So what do? You just go to tab and you put these two functions in. So how do I get the arcsine? You go to trig, and then it's this one, right? Okay. So here are my two functions, and it looks like they are perpendicular, and it also looks like x equals 0, y equals 0 is the point of intersection. We can quickly check in a minute. So let's see. First of all, let's make sure that 0, 0 is a point of intersection. If I plug in 0, 0 here, it works. If I plug in 0, 0 here, it's also on the second graph, so indeed it's a point that is on both graphs. So that is my point of intersection. How am I going to find the slope of the tangent line? For the first function, y equals negative x, the derivative is just -1. So it's a line, the slope is -1 everywhere. For the second one, we haven't actually studied how to find the derivative of y equals arcsine x, but we do now know, using implicit differentiation, how to differentiate an expression like this. The derivative of x is 1, the derivative of sine y is cosine y times dy dx, because we are differentiating in terms of x. So when I'm differentiating in terms of x, I don't need to add times dx dx, but when the variable is different, y, then I need to multiply by dy dx. It's the inside derivative. And that means that dy dx is 1 over cosine y. Right, so this is y prime. So what is the slope at the point 0, 0? At 0, 0, dy dx, which is y prime, is 1 over cosine of 0, and cosine of 0 is 1, so I get 1 over 1. So I can compare my slope, slope of -1, slope of 1. Yes, at the point of intersection, the two tangent lines are perpendicular. That's it.